Most of us learn in school that Earth has 7 continents. This idea feels very fixed and certain. We grow up seeing maps that divide the land into Asia, Africa, North America, South America, Antarctica, Europe, and Australia. However, when scientists study the Earth more deeply, they sometimes discover that nature does not always follow the neat borders drawn by humans. New geological research suggests that the true structure of Earth's continents may be more complex than what we see on the surface. When scientists look beneath the oceans and thick layers of rock, they find evidence that some continents may still be connected deep underground. This does not mean the oceans will disappear or the continents will move back together in our lifetime. Instead, it means that the Earth's crust beneath the surface tells a story that is still unfolding. To understand this new idea, we must first understand how geologists define a continent. A continent is not defined simply by land above sea level. Instead, scientists focus on the type of crust beneath the land. Earth has 2 main types of crust: continental crust and oceanic crust. Continental crust is thick, light, and very old. It makes up the main land areas where people live. Oceanic crust is thinner, heavier, and much younger. It forms the ocean floor. Even when land is hidden under water or covered by lava, scientists can tell which kind of crust lies beneath by studying gravity, seismic waves, and rock composition. Because of this, a continent can exist even if it is buried under the sea or hidden by volcanic rock. Earth's outer layer is broken into large pieces called tectonic plates. These plates slowly move over time. Sometimes they crash into each other, forming mountains. Sometimes one plate slides under another, creating volcanoes and earthquakes. And sometimes plates pull apart. When plates pull apart, the crust stretches, thins, and eventually splits. This process is called rifting. Rifting usually leads to the formation of a new ocean. Magma rises from below, cools, and becomes new oceanic crust. Over millions of years, the gap grows wider, and land that was once connected becomes separated by water. For a long time, scientists believed that when continents split apart, the process was clean and complete. But new evidence shows that this is not always the case. In some regions of the world, scientists have discovered thick layers of volcanic rock covering what appears to be continental crust. This means that the land underneath did not fully break apart. Instead, it stretched and sank while lava poured over it again and again. These hidden areas are difficult to study because they are buried deep below the ocean and thick volcanic layers. However, modern tools such as satellite gravity measurements and seismic imaging allow scientists to see below the surface without digging. What they are finding is surprising. In some places, continents that were thought to be fully separated may still be connected by deep crustal structures. In some parts of the world, continental separation did not end millions of years ago. Instead, the crust is still slowly stretching today. This stretching creates cracks, volcanic activity, and weak zones in the Earth's surface. These regions behave differently from normal ocean floors. The crust is thicker, older, and more complex. This suggests that the land is neither fully continental nor fully oceanic. It exists in between, forming a wide transitional zone rather than a sharp boundary. This idea challenges the traditional picture of continents as clearly separated blocks. One of the best ways to understand continental breakup is to study places where rifting is happening right now. In parts of East Africa, large cracks in the ground show how the land is being pulled apart. Volcanoes, earthquakes, and deep valleys are common in these areas. Scientists notice strong similarities between these active rift zones and some volcanic regions found in the middle of oceans. These similarities suggest that some ocean islands may not be simple volcanoes rising from the seafloor. Instead, they may sit on stretched continental crust. Studying these regions helps scientists understand what early stages of continental breakup look like and how long the process can take. Rather than continents splitting into 2 neat pieces, the breakup process can be messy. Pieces of land can tear away unevenly. Some fragments become small islands. Others sink below the ocean. Some remain attached beneath thick layers of magma. These fragments are called microcontinents. They are not large enough to be continents, but they are made of continental crust. Over millions of years, they preserve valuable information about how Earth's surface changed. Discovering microcontinents shows that Earth's crust does not behave like a cleanly broken plate, but more like stretched fabric that tears in unpredictable ways. Understanding Earth's deep structure is important for many reasons. First, it helps scientists build more accurate models of how the planet works. This includes how mountains form, how oceans open, and how volcanic activity begins. Second, it helps explain why some regions have frequent earthquakes and eruptions. Areas where the crust is still stretching are often unstable. Better knowledge of these zones can improve disaster preparedness and safety planning. Third, these discoveries help scientists rethink old classifications that may no longer fully represent reality. Many natural resources are closely linked to ancient rift zones. Oil, gas, and certain minerals often form in areas where the crust was stretched and heated long ago. Knowing where continental crust exists beneath the ocean can help guide responsible exploration. This knowledge allows industries to reduce guesswork and focus on regions with higher potential. At the same time, it helps governments and scientists balance resource use with environmental protection. Better geological understanding leads to better long-term decisions. Deep geological research also plays an important role in renewable energy. Heat from inside the Earth can be used to produce geothermal energy. This clean energy source is especially powerful in volcanic and rift regions. When scientists understand the structure of the crust, they can identify places where geothermal systems are strong and stable. This reduces drilling risks and increases efficiency. As the world looks for alternatives to fossil fuels, understanding Earth's internal heat becomes increasingly valuable. These discoveries would not be possible without modern technology. Satellites can measure tiny changes in gravity that reveal differences in rock density below the surface. Seismic waves from earthquakes travel differently through various types of crust, allowing scientists to map underground structures. Computer simulations also help researchers test ideas about how continents stretch and break apart. By combining different tools, scientists build a clearer picture of Earth's interior. As technology improves, even more hidden features may be discovered. Advancing our understanding of Earth depends on education and training. Young scientists bring fresh perspectives and often question long-standing assumptions. Universities and research centers play a key role by offering hands-on experience with fieldwork, data analysis, and modeling. When students learn to study Earth as a dynamic system rather than a fixed object, new discoveries naturally follow. This keeps science moving forward. Even though continents seem permanent, Earth is always changing beneath our feet. Tectonic plates continue to move slowly but steadily. Processes that began tens of millions of years ago are still shaping the planet today. By studying these movements, scientists gain insight into the future of Earth's landscape. This knowledge helps humanity adapt to natural changes rather than be caught unprepared. The idea that Earth's continents may be structured differently than traditionally taught does not mean old knowledge was wrong. It means it was incomplete. Science grows by building on past understanding and refining it with new evidence. Rather than focusing on the number of continents, scientists are now more interested in understanding how Earth's crust behaves over deep time. Earth's continents are not simple fixed pieces of land. They are part of a living, moving system shaped by heat, pressure, and time. Beneath the oceans and volcanic layers lie stories of stretching crust, hidden connections, and unfinished breakups. As scientists continue to explore the deep structure of the planet, our understanding of Earth becomes richer and more accurate. These discoveries remind us that the world is far more complex than it appears on the surface, and that there is still much to learn about the planet we call home.